Okay. I am Isabel Ely. I am talking here from Northern Australia. So pretty much nearly 3 o'clock now, 3 in the morning. I would like to start acknowledging Varai, Kungaranka, and Maranangu people, the traditional owners from the lands where we have been working on. And what I will be sharing with you today, it's a data about the metal assessment of the long-necked turtle Chelodina rugosa, or Chelodina rugosa in English, in the Finniss River floodplain in the northern Australia. And this is my team. So we are working at the Charles Darwin University with some partners. So the long-necked turtle, the Chelodina rugosa, was Chelodina rugosa then changed to oblonga, now it's rugosa again, belongs to the family Chelidae. The distribution of this animal, as you can see on the map, it's on the south coast of Papua New Guinea, Indonesia, Papua, and northern Australia, so this tropical region here. This animal, the status of this animal at UECN, it's near threatened now. And the habitat of this freshwater turtle, it's lowland waterways, billabongs, and seasonal wetlands on the coastal floodplain, as the first speaker has covered a little bit. So in the dry season, this turtle buries itself on the mud and estivates for a few months. It's how it survives to the dry season here in Australia. And when is the good time to find the turtle. So the diet of this turtle is carnivorous. It sweeps from crustaceans to fish, tadpoles, frogs, and aquatic insects and invertebrates in general, aquatic invertebrates. And that's an interesting point for this species to investigate heavy metals, because as a carnivorous, the long-necked turtle, it's on the top of the food chain. The other one that could be higher would be the crocodile or even the humans. So Aboriginal people love to eat this species of turtle. So because of them, and because the harvesting and the preparation of the turtle, it's a vital element for Aboriginal culture, we went to the field, me and my supervisor, who is Carla Isenberg, and we were interviewing these traditional owners. As you can see in the first picture here, we have an elder woman. This is a businesswoman here in Australia. She's probing the mud with a stick. That's the traditional way to find the turtle. And she heard a knock. It's because she found the shell and then she grabs. There you can see the turtle. Here's a juvenile on her hands. And then they cook it. They cook it, the whole turtle. They eat the whole turtle, but not the shell. So in the past 6 years, the traditional owners from the Finniss River, they have expressed concerns about this turtle. So according to them, we have done some interviews. Since 2008, these turtles are tasting different. They are skinnier, the yellow, the fat is yellow, not green. They used to call the turtle as the bush avocado. So it's a very beloved turtle. They have noticed some differences on the health of the turtle. So we went to the field and we got the threat assessment, but that's too broad. So I came here to talk only about one hypothesis, that's metal contamination coming from a mining site. The mining site, it's Rum Jungle, uranium copper mine that starts on the 50s and it was running until the 70s. So the Rum Jungle mine it works here in Australia to supply nuclear weapons to US and British government. It was the major industrial development in the northern Australia at the time, and it got very famous for its high pollution in the river where all the biota has disappeared on 70s. So on the 80s, they start the first rehabilitation, and they say they got 70% of the environment rehab. Not only the destruction of the environment, the mining also was built actually in a sacred site, woman's sacred site for Aboriginal people. So we still now, they are trying to rehab this year. They start a new project where they are investing more than 200 million Australian dollars to try to clean the water actually and the rock waste as well. So the methodology, here on the map, you can see where is the Finniss River floodplain, where we have been working. The Rum Jungle, it's 60 kilometers from the floodplain and 100 kilometers from Darwin. This picture here shows the open cut mine on 50s and how it was. The methodology was really simply, we just joined the traditional people to go for harvesting their turtles. That was in August of 2018. So pretty much like this time of the year, it's good for them to find them. And then we found in two sites, 4 alive turtles in one site where we collect carapace, skin, liver, and fat before they cook and eat. And in the other place, we found dead turtles, 17 dead turtles. And then we collect from the shells, it was only empty shells. And then we could collect carapace and skin only. So these samples, they were analyzed in laboratory here in Darwin for those metals here. And for mercury at ANU with Larissa Schneider. She has made the analysis of mercury for us. And with some analysis, statistic analysis, we could compare the areas and all the tissues as well. So the results, we had 21 turtles, as I said before, and 36 samples. The mean LCL was 172.5 millimeters. And among dead turtles, 41 were juveniles and 59 were adults. And these results corroborates with Kennett's 2014, who has done the population structure study with the same species. And here we have the raw results for all the metals, all the tissues collected in both sides. That's complicated to understand, but that's the mean, and then the deviation, maximum and minimum. And this slide is just the results that we got from statistic analysis. So chrome, manganese, and zinc follow the pattern carapace, skin, liver, and fat. Iron and copper follow the pattern liver, carapace, skin, and fat. Cobalt, nickel, cadmium, and lead, skin, liver, fat, and carapace. Mercury were higher in levels, higher levels on the carapace than skin. On site 1, where we had the healthy turtles, I mean the live turtles, with fresh tissues, we had liver, skin, fat, and liver, skin, and fat. And on site 2, analyzing the shells, we found that carapace had higher concentration of heavy metals than skin. The statistics analysis shows some differences among the sites on skin, because it was the only tissue we had in both sides to compare. So chrome, zinc, cadmium, and lead had some significance. On site 2, when we compared the tissues, we had all the metals with some difference, but not iron and nickel. And on site 2, we could compare skin and carapace, and then we found difference on chrome, nickel, and zinc. So what we can conclude for a few points from these results, based on the generally expected levels by the food standards Australia, New Zealand guidelines. However, these guidelines are for fish. We don't have guidelines for turtle meat. It does not appear to pose a risk for humans, or I mean the indigenous people eating these turtles. Not for the amount of turtle they consume. The harvesting of the turtle here is very sustainable. So it's just a period of the year they can eat it. The mercury was higher in the carapace, which is not a consumed tissue. So it was higher than the skin. Of course, the skin has keratin as well. So we can understand by this order in the literature that the keratin from the carapace can accumulate more mercury because of the scutes on these keratins. The keratin is a metal binding protein, easily accumulates mercury. Just checking my time. So that's lead and cadmium were higher on site 1, where we found these 4 alive turtles. And this site is further from the Rum Jungle mine site. So how could we explain that? It's because of maybe metal mobilization through the floodplain, or it could be a result from the rehabilitation from the Rum Jungle East branch, which is closer to site 2 on 80s. Metal concentrations pattern liver skin fat are similar to other freshwater turtle species and some sea turtles as well. Metal concentrations are usually higher in liver tissues because this organ is responsible for detoxification, and that was actually very expected. And of course, we had 6 months to develop this project, so we found some interesting results here, and we need further analysis, including collecting turtles, and that's what we are in the process now to get funding to keep doing this work and collect more and see if it is safe and how safe and how much people can eat. The turtle looks okay, and would be interesting as well to make a physiological analysis of the turtle to see if it's everything okay with them, with the population. So these are my partners. I would like to thank you, all of them, and all of you guys as well to be watching. And that's me. Just here I have the chat, some questions, right? Question 1. Historically, have there been any other kind of turtles that have been contaminated with metal and people have seen similar conditions? Not really. I didn't find anything about skinnier and yellow fat. They always say the fat is bubbly, so totally and yellowish, not more for white, not so yellow and green like before. So that's something really interesting we have to investigate. And that comes from the communities, not only one community, some faraway people that lives and eats and really get some protein, not the main source of protein, but it's a good source of protein, and also iron. So I invite you guys all to watch in 5 weeks, Carla Isenberg talking about the iron we found on this species, the same turtle. And that's really interesting point that she will be talking about. I won't say anything, it's just a merchandise for her. Question 2, what part of the carapace was specifically tested? Was it bone, marrow, within the plastron bridge, or scutes? The scutes only. So we can't collect bone to do this analysis because it gets different, they are different tissues. So we have been collecting only the surface of the clean carapace, taking only that keratin, like the same material would be the hair or nail. One more, creatures unseen. Did they compare heavy metals in water samples of the habitat or prey species versus what was in the turtle tissues to access bioaccumulation? Not really. This is not a bioaccumulation project. That's the next step. That's what we want to do. We want to collect the water. We want to collect also the sediment along the river, since the Finniss River would be interesting to go a little bit in the bottom of this river before the rum jungle. It's a small place there because they start the mining right in the beginning of this river. So we want to compare the samples from sediment to the turtle's tissues and also all the food chain for this turtle.